Hey guys, today we are finally getting to the long-awaited nebulas, which are the first main feature of the game, which will use everything we've used so far, production, upgrades, and actually more interactions for the player, and actual decisions, right? Because so far, the only decision the player is making is, do you actually want to unlock nebulas right away, or do you want to increase your Stardust production before? Right? That's the only decision they have. So, yeah, let's get into it. I actually haven't started Godot, but we will start as usual by making a view. Making a view is the very first thing to do, and actually very convenient because I'm already in the user interface script. So let's create a new Nebulas view in the enum. All right. And now we can create a new button link. That's going to be a button link. Nope, don't have this one. Link button. Okay, my bad. So I will rename it Nebulas link. Seems good to me. Need a placeholder. Nebulas link. All right. And a connection. Pressed user interface on Nebulas linked pressed. Perfect. I will just copy this. All right. And open Nebulas. So now we have the link, which appears there, but there is one thing I want to do with this link, and I actually want the link to be hidden as long as the player hasn't unlocked the Nebula features, right? So I will actually need to create a script for this button. So let's create Nebulas, Nebulas link button in user interface, right? I actually don't want to give it a class name. It's going to be an anonymous class. I've done it already in the series if you have followed, but it's okay. So all we have to do really is to have a ready function, which is going to check whether or not we have unlocked nebulas. And if we didn't unlock nebulas so far, we actually need to watch on CCU03 level up. So we will check the level of the CCU03, and if we don't have it, then we have a new signal being watched. So now we have the button, and if I actually start the game right now, the button should be hidden, right? And if I just wait a few seconds, and there we go, Nebula has appeared. Perfect. Now we can move on. The next thing we want to do is obviously create a new view. So let's create a new scene right away. Have this Nebulas view, and I will create a script. Wait, let me save it first, and I will create a script later after. So we need a new folder, which will be Nebula and NebulasView.tsc. Here is the script, which will be 9, and it does extend view. The only thing we need to add from the view abstract class is the ready function as well as the super instruction. Just to make sure that we don't forget later on to add the super instruction, we will just add it right away like this. Just to remember, keep this. All right. So now we can import a new view in there. in the user interface. We can import the view and set what we need to set, which is the user interface here. And also we need to update the enum, so I will reload Godot right away. Okay, we're back, and we can now change the Nebulas view into Nebula, just to make things perfect. All right, so we added the view. Let's just make it visible view in there, because we will be editing it. There is one thing that I discovered. If we go in the consciousness core view, the margin isn't the same as in the universe view, and actually I prefer the one from universe view, so I would just give a 64 margin on all sides of consciousness core view, right? So now I will just commit what we've done so far. There is another little trick that I like to implement, which is from this commit, and that is actually using those two exponents instead of this per second display, right? So I will just go in my active effects component script, which is there. That's weird. I think it got misplaced when I saved it. I will have to look into it later on, but anyway. Okay. Now we are done with creating the view. So let's go inside this view and add a few nodes to make it a little bit prettier. So the usual margin will be useful. What's your problem? All right, let's just ignore this. It's probably nothing. So 64 on each side is always a good go to. Vertical box to initialize the vertical alignment, and as usual our label, which will be the main header. Prototype clicker, oh right, he's missing on those things. It's not so bad then. I didn't clean the folder Godot folder. Anyway, that's gonna be the header, and I will name it Nebulas. All right. I will change the VBox separation to 16 and add a separator. So we need a margin. Actually, you know what? I'm just going to copy it from consciousness core. Copy and NebulaSView paste. All right. Now we have the separator and the header. The last time I did a kind of indent for the section. I think I will do it again. Let's have margin. Yes, let's have margin. Take all the space and have a left value of 64. Right. I'm actually anticipating this view growing very fast in vertical size. So I will anticipate and add a scroll view. So I will add a scroll container, which will take the entire space here. And there I actually need some content. Okay, so I will actually use another margin because I don't want the content of the margin to be sticking to the side. I want it to be a little more spaced. So I'm added another margin, which is going to be 16 on all sides. And let's get into how scroll containers work. Scroll containers define a space in which you will have lots of content, and then with the scroll bar you will be able to navigate within that content. So the actual space of the scroll container is the view space, the view container, right? And then inside of it, you can have a container which goes higher than the space of the view container, the scroll container, right? So this margin container can grow bigger, and it's fine because with then we'll be able to scroll through it. So let's just go into the very few options we have. Photo focus, not necessarily. Horizontal scroll, we want it to be disabled actually. We just want the vertical scroll. And we want, yes, we want to always show the scroll bar, right? And there we have other values which are not important for us right now. All right, so we do have a scroll zone, okay? And that's it. The next thing we will do is add another VBox in this margin to actually start generating the nebulas. But at the moment we don't know what nebulas do, so maybe we will jump into the script. Creating nebulas begin by creating an abstract class. So we could be doing like we did with the upgrades by creating the upgrade first and then implementing the abstract class later. But this time we will do it abstract class first. Okay, so let's create a script nebulas which will describe what a nebula is. So nebulas, what do they do exactly? In our game, nebulas will be objects that the player can create and then manage. The idea is that nebulas will actually consume Stardust to feed, sort of. So over time, the player will be able to choose how much Stardust he wants to be given to one nebula or another nebula, right? So, and then the nebula will just go pick in the Stardust storage the right amount of Stardust they are consuming every second to add it to their what we will call composition. Okay, so the composition will be the content of the nebula. The very first thing we will focus on is making the nebulas functional, consuming Stardust, and having their composition building up as they are consuming Stardust from the universe to actually, well, it's not consuming really, it's displacing the Stardust which is nowhere into nebulas, right? So let's start with the properties. I decided to name this variable given name because we can't use the word name actually. Name is a variable taken by node. So if we do this, we will have an error which says you can't. Node already has a name. So given name will actually be the name the player will choose for the nebula. So that will be something we'll take care of later. At first, all nebulas will be unnamed nebulas. I think there's two unnamed nebulas. Right. The common thing all nebulas will have is an amount of stardust within the nebula, right? So we'll have the stardust value, right? Which has to be initialized to 0. Another thing nebulas will have in common is stardust consumption. So they will have a stardust per second, shall we say, uh, value, which is going to be an int. So maybe we can name this stardust consumed. That sounds right. This is going to be an int because we don't want to deal with decimals for Stardust. So Stardust consumed, and that's the amount that is consumed every second by the nebula. All right. We actually don't need anything else at the moment. The logic will be more about other places in the code, especially data and the Nebula handler. So maybe we can start right away by creating the Nebula handler. Alright, so I created a script HandlerNebulas, which will be the Nebula handler in the game. Since it is a handler, as usual, we will make it a singleton by using our classic singleton pattern. I'm actually gonna go fetch it in another script just to copy and paste. Okay, so we now have a singleton handler. Um, let's actually add it to the game right away. So we do not forget later on. We need to manually create this. Is it in handlers? Yes. And that's going to be Nebulas. Now we just need to bring the script in as usual. All right. We now have a functioning handler ready to have more instructions. What the handler will do is manage the current nebulas we own. So it will actually need a list of nebulas, right? So let's have a variable, or maybe is it, at first it will be a method. We will have a method which will return the amount of nebulas we own, okay? So function gets all nebula. There is a catch though. Nebulas, unlike upgrades, they are actually more data driven rather than code driven. What I mean is that upgrades are already pre-coded, sort of, and we know that we have a limited amount of upgrades and we know what upgrade does what. For nebulas, it will be very different because those will be objects created by the player. So the main source of informations for nebulas will be data, right? So nebulas will be stored in data. The easiest way to store this kind of object is using an array. So by using an array, we actually can list all the nebulas, well, in a list. And then what's going to be very important is the index of each nebulas, right? So we will actually need to have local nebulas objects, which are going to be in the handler, and we will have data or save nebula objects, which will be in the data object. And the main thing which will allow the script to know what nebula you're talking about is what position within the array the nebula is at. So in other words, we need to create our nebulas as usual by loading them and associating a new variable which is going to be the data index. Okay, so maybe can just add this one within the nebula so that when the nebulas are loaded, the handler can assign to those nebulas an index and later on retrieve this index and use it as necessary. I added a new variable, data index, in our abstract nebula. In there, I gave it a value -1 by default, right? Because it's meant to be overwritten by the code, right? So now maybe we actually could get into the data object and create data that we need to load for each nebulas. So let's go into our data folder. Okay, so here we have data, data CC upgrade, data universe, and save system. So we'll need to create a new data nebula resource. That's going to be data nebula. Yep. So data nebula needs to be named, and it needs to extend resource, because resource are what we save. So what are the actual values we do want to save of the nebula? We do want to save the name. That's going to be var. We also want to save the amount of Stardust. We want to save the consume Stardust per second, right? Because if the player set it up, he wants to have it back when he loads the game. The index, though, isn't necessary here because, well, it's going to be the position in the data index. Okay, so not necessary. Right. So we now have a single data object. So what is necessary is to actually have a place where we will store all the nebulas of the game. So that will be in the main data class. Here I will have export variable nebulas, which is going to be an array of nebula. Sorry, DataNebula. Actually very important. Good. So we now have a Nebulas object in the data, which our handler can go get and retrieve the data from. So let's get back to the handler and initialize a list of nebulas based on this object here. Maybe we can initialize this into an empty array just to be sure. We are back in Nebula. So from what we did earlier in the series, we should have the game loading the data before any handler is actually created. So we can now create a new method, which is going to be load nebulas basically. And we also want to create a ready function that will load on ready, well, before getting ready. So here is our methods, which are empty at the moment. Let's create the very first one, which is going to be load nebulas. We will actually create nebula object, which will mirror the nebulas we have in the save file, right? So here we will have an actually list of nebulas. All right, so we have a list that we need to populate. In order to load nebulas, we will make a simple check first to see if we do have nebulas in the save file. And if we don't, well, it's easier. We have to load nothing. So very simple. If we have an array of nebulas which is equal to 0 or empty, then we will instantly stop loading because there's no nebula to load, right? Otherwise, we actually do want to load the nebulas, so we are just going to go through the list of nebulas. Here is a simple for loop which will go through each each element of the nebulas table. So what we will do is create a new object, and then we will assign to it the various properties and values which are related to the loaded nebula that we have in the save file. Here is the full code of this method. So what we do is we create an empty array which will be assigned to nebulas because we want to be sure we're not adding nebulas to a list which already has nebulas in it or whatever. We want it to be clean. Then we initialize an index which will create the connection between the data nebulas and the actual nebulas we have in the handler. And then we populate. We populate the new nebulas by assigning all the values to it from the data. We finally add it to our nebulas list here in the handler. So now we have a list of nebulas, but it actually assumed that we already have some in data, which might not be the case necessarily. So we will need to actually create some methods which will allow us to create nebula, all right? First, I actually see this method here which we created and actually does nothing at the moment, so it would just return nebulas and that will be fine. Okay. Oh yes, it's a no return function. Let's return an array of nebula. Cool. We do have a warning for iterator inputs. Okay, yes, there's no static typing. It's all right. It's going to be DataNebula. And now you're happy. Cool. So let's have this thing, right? Creating a new nebula. Here, we just create a new nebula object. We actually don't need to initialize anything because it is already in the nebula abstract what happens when you initialize a new nebula. So Stardust being 0, Stardust consumed being 0, okay? Then nebulas.append new nebula, because we simply add the new nebula. Oh, I didn't talk about the index. The index is going to be equal to the size of the table before we add it to the table. So here is a quick explanation. If there's two nebulas in the list, then the first will have the index 0, the second will have the index 1, and the third, which we created, will have the index 2. And 2 here is the amount of nebulas which was in the list before we added. Right? Cool. Now it is actually necessary to also add a nebula in the data as we are creating one in the game. So here we will have to make a new nebula, DataNebula, which will be added to data.nebulas. Here are the instructions of creating a new DataNebula and adding it to the data array. We just create a new DataNebula.new and assign to it all the values which are from the abstract nebula. So we do have the actual values of the abstract nebulas. We don't want to be saying 0, 0, unnamed, etc. here, because if for some any reason those values must be changed, well, that's where. So now we do have a possibility to create nebulas. We do have possibility to get all the nebulas from the game, but nebulas do nothing. So maybe we can create just a simple Stardust consumption based on the few variables we do have, right? So let's get into our Nebula object. Let's create a simple Stardust consumption method. This method will be triggered by a signal that Nebula's handler will be giving. We basically want the nebulas to try to consume Stardust, and if the consumption is, well, it is working, then it will add this amount of Stardust to its composition. If you don't remember, when we do consume Stardust, we actually want to grab an error to know whether or not we did succeed at consuming the Stardust or if there was any problem. And here the problem being you don't have enough Stardust. So what we're doing is just grabbing the error and then making the checks. If we have an error, we instantly stop process, and if we don't, we actually add the amount of Stardust being consumed to the amount of Stardust composing the nebula. Now we have consumed Stardust, and it is actually important that we do change this value in the game data as well. So after the consumption is successful, we do want to save the amount of data we have consumed. We do grab the nebulas list, and more specifically the nebula that share the data index as this one, with this one, and we want to change its Stardust value to the Stardust value of this node. Now it is necessary to make sure that this method is actually connected to a timer. The timer could be individual to each nebulas, or it could be related to the handler. I think at the moment it will be better to have it connected to the handler and not the nebulas. So let's create a timer for the handler. Okay, so here we have the handler owning a timer which we want to be auto start. Right? We have no reason not to have this timer running around. Well, actually there's no nebulas, but that's optimization we could be doing, but really nebulas will be here for pretty much all the time. If we do this optimization, that will be in a later episode. So right here, now that we have our nebula's timer, we actually want to connect this timer to each nebulas in the list. So when we load a nebula or when we create a new nebula, we want to connect the timer to this new nebula, right? So we need a reference to this timer, and then we will be able to connect the signal. Here is the instruction, alright? We grab the timer, we find the timeout signal in there, and we connect it to the onConsumeStardust method from the Nebula object. And we do the same to this Nebula object here. So we can copy the line, add it there, and actually have this. Oh, it's new Nebula as well. Well, cool, I guess. Now we have those two nebulas. We actually need to create something, well, most likely a button to create nebulas, and then something to display the content of a nebula. So we will need to create a Nebula component as well as a button to create the nebulas. So now we are back in NebulasView. We can start by simply creating the button, which will allow us to create a new nebula. That's the easiest thing to do, I think. So let's just add a VBox container in there, which will, well, take whatever. And we will add a, I actually want my button to have a margin. Well, let's add just the button there. We will care about the design later. All right. Here, let's keep things simple. Just create a new nebula button. I do want to add a separator here, and I also want to change the spacing of my VBox to be 16 pixels as usual. So let's finish this, create a new nebula button. We actually need to have this connected to something in a script. So let's have a signal coming from pressed and have this right into NebulasView, right? So on button pressed, we actually want to go in the Nebulas handler. Maybe we can make a reference to Nebulas handler. Yes. Here we want to simply use the create function from the handler. Now it's actually a matter of creating an object, a component that will display the nebulas, the unnamed nebulas, the amount of stardust it owns, and the amount of stardust it consumed. So I'm creating a VBox to organize the content of the nebula, and I start with just a label, which is going to be a header median to, well, display the name of the nebula. Then I will add a separator. And we actually want to show the amount of stardust in it. So that's going to be a rich text label. And then we actually want to add a little slider that will allow us to modify the value of stardust we want to consume. Right, so here I created a little slider, a horizontal slider, to basically allow the player to change the amount of stardust they want the nebula to consume. So here it's a little bit all sticked together, so maybe I can change the constant here. Yes, it's not 16. Yes, be a little bit better if it is 16. The slider at the moment, I only want the player to be able to consume as much as 5 Stardust per second. It's going to be the base value. Right. So here we have a very basic component, which is only displaying the amount of Stardust, as well as having a slider allowing us to change the value of Stardust consumed per second. So let's create a script for this component so we can modify the actual values of the nebula. Right, so now we have the script being created, so it's all a matter of populating this script. Here we have a few basic properties which will allow us to have control over the different elements within the component. So we just need to connect those things from the editor. This is going to be the label name, label composition, and the consumption slider, right? So here we do have a nebula that will be given before the node is actually added as a child to the tree. So we can create the update functions, which will, well, update all those components in there with the values of the nebula. Just like we reworked the upgrade component the last time, here we will have distinct functions to upgrade each component of the component. And we have a main function which updates everything within the component, right? So now we do grab those informations and we actually need to connect a few signals. For example, when we do consume Stardust, when we have something which are changing, increasing, all right? Here I want to bring your attention to the slider. We do have a value being changed in there, okay, as a signal. So when the slider is being interacted with, it does emit a signal that must change the value of the nebula within the handler and within the game data, right? So that's something we will have to take care of. So let's create a method in the Nebula component. Here we can do this in many ways. We can have this component doing all the dirty work, but it's probably not the best way to do so. I think it's probably better just to have the handler doing that for us, right? So let's get back to the handler and create the various signals we need in order to update the Stardust here, as well as a method which the slider will be able to call on when it is triggered. Here is the method that we will use to update the consumption of a nebula, we will need the index and the value, the new value. So it's pretty simple, right? We just get the list, get the index in the list, and change the consumption value. It is this simple, really. Now that we have the method, we must go back into the Nebula component so we can invoke this method from the component. We actually need another signal, first signal actually, in the Nebula object, which will allow us to update all the interesting components when the composition is being updated. So let's jump back to the Nebula abstract object. Here we will be able to create a signal. Right, very simple. We just create the signal composition updated and we emit it. Okay. Now it's just a matter of going back to the Nebula components, grabbing the signal and connecting it to the update label composition. Right. Now we should have this label updating when the composition is updating as well. The very last thing we must do is to make sure that the list of nebulas which is being displayed is actually the one which is in the data and not, well, this fake one. So we actually need to save this nebula as a new component. So let's save this as scene nebulas component nebula and have, well, yes, nebula.tscn. Okay. So now we can get rid of it and open it in its own scene editor and check that everything's fine. No, we need to reassign those. It's alright. Maybe we can give it a little bit more white. Okay. Make it a little prettier. So here is our component. Now we actually need to be in our NebulasView. In there, that's going to be, I'm going to name this main list. And there we will need to have the view creating the nebulas when it is necessary to create nebulas. Okay, so we created a few properties which will allow us to link the important nodes. So here we want to display the nebulas in the main list, which is here, and the components which we want is in scene views nebulas, components, and nebula. All right. Now we do have the component. We do have the location to have those components to be added. And well, we do actually need to create those nebula. So here, this function, this method, will generate all the nebulas in the list. All right, so we'll take on the full list and generate everything. But we will also need to generate a single nebula at some point, which will be when we create a new one, we actually want to generate only the last one. Okay, so here it's quite simple really. We just check that the size is superior to 0, otherwise we just don't do anything. And we will just take on the full list, and for each nebula we will create a new component, give it the values, and then add the new node to the list. Quite simple really. Now we're going to make sure that this happens already. We want to generate nebulas, right? And let's jump to the generous newest nebula now. Here we just want to generate the very last nebula which was created. So logically it is the nebula which is at the very end of the list. So we will actually get the size of the list here. That's going to be an int, and we will get handler.nebulas.size, right? So here, let's say that we have 10 nebulas being created. Then we do want the very last index, which is 9, which is size minus 1, because we start at 0 and not 1. So here, when a nebula has been created, take the size, we go in creating a new component. So that's going to be our new node, which is a CompoNebula. We will instantiate the as nebula, as CompoNebula. We'll have the new node, and then new node dot nebula will be equal to handler.nebulas, and here we want the index size minus 1. All right. And now that we have this, we can add the nebula to the main list. I want to add child and new node. This method actually must be waiting for a signal, right? So the signal we will be listening to is one that doesn't exist so far. So let's create this signal. In HandlerNebula, we do want to create this new signal, which will be there, and that will be simply Nebula created. All right. Now we need to emit the signal when we do create a new nebula. So here create nebula, and we want to emit the signal. Nebula created dot emit. All right. We can go back in the Nebula's view, so that already we go in the handler, grab nebula created signal, and connect generate new nebula. Right. We do have something here, the variable size is shuttering. Okay, so let's have this named table size and use table size instead. Right, cool. Honestly, at this point, I don't know how this will happen when we actually launch the game. Let's give us some more consciousness scores on start, so we can have 5 maybe. Right, so we have no nebulas. That's a good thing. Now, when I create a new nebula, 1 new should happen. Right, that's a good start. We created a new nebula, and now I should actually be able to change the slider. All right, so it is actually consuming Stardust here, which is a good thing. There's a little problem. There's still no value being shown here. which is kind of weird. Let's check on this. Right, I have found the problem. The problem is simply that I actually did not create a ready function in the component Nebula. So here I need to update my component, and its signal connection here is actually not meant to happen here, but instead happen in the ready function. So now I should actually be able to start a game again, create one nebula, and increase the amount of Stardust being consumed. Let's have more Stardust being consumed, right? So created, I mean. So now we can have 6 per second, so we can consume 5 per second and have new nebulas. And actually, let's see what happened when we have 2 nebulas, 3 nebulas consuming everything. Have some nebulas which fail to have enough Stardust, and only the first one gets the Stardust, right? So it is actually working very well for a single error thing. Yes, that's gonna be it for this episode. I'm very tired. It's 1 hour 42 minutes of recording, and the point of this episode is not to get Nebulas fully functional, fully fleshed out. Like this will come in later episodes, but I actually wanted to have something which, well, works already. So we do have those things, right? Nebulas can be created. So at the moment we have an infinite amount of nebulas we can create, which is okay. And well, they consume stardust. That's the point. So that will be it for this episode. Let's just jump into Git Kraken to commit this. I was actually taking one unit equal one commit, but I completely forgot about it when I was doing it. So let's just go with, hey, nebulas are here. That's kind of, yeah, meh. So anyway, thank you for watching this very long episode. I hope you liked it. I think you did, because I do think that people prefer episodes with actual features, with cool stuff, rather than refactoring and cleaning and that's kind of boring things we have to do anyway. So yeah, thank you for watching, and I see you in the next episode.